Hi everyone, here we go on Chapter 5, the second half. This is doing a lot with proportions and then a little bit with some transformations here toward the end. So let's start pounding through the review. Check your work. Make sure that you are showing work on all of these. So let's start with number 1. Which rectangles are similar? Now, I don't necessarily like the way the program set this up, but these numbers on the inside are not the areas. That's referring to, this is rectangle number 1, this is rectangle number 2, this is rectangle number 3. So now just kind of, if you want to rewrite that and ignore these numbers on the inside, that might make it a little easier. Okay. Which ones are similar to each other? So what you need to do really is check the ratios of each one. This one, if I'm always going to set up my ratios as the length to the width, my ratio for rectangle number 1 is 4 to 2. This one, oops, careful, it's turned. This length is 12. 12 goes on top. 12 over 9. Are these guys equal to each other? 1 and 2? If I check cross products, 36, 25, nope. So I know 1 and 2 aren't similar. The third one, length over width, is 20 over 15. All right, well, if I try to check the first one to the third one, you could either do cross products, the 4 and the 15 and the 2 and the 20, or you just say 4 over 2 is the same as 2 over 1. 20 over 15 isn't a double over 1 relationship, so it's not 1 and 3. Take a look at 2 and 3. That looks like my last choice. You can test these two by getting them both in simplest form, or if you want to check cross products, first of all, simplest form way, I would get 4/3, and then dividing by 5 and dividing by 5, I get 4/3. Or 12 times 15, that happens to be 180, and so does 9 times 20. End up being exactly 180. So regardless of which way you do it, it ends up being that the first one and the third one are similar to each other, which is, second and third one, choice C for number 1. Let's move on. Number 2. Mona needs to photocopy an 8 centimeters wide by 12 centimeters long picture. Okay, now stop right there. I cannot even think about this till I get a picture drawn here. 8 centimeters wide, 12 centimeters long. Okay. She wants to enlarge the picture so that its length will be 36 centimeters. Length is this one. How wide should it be? All right, well, you can just look proportionally at this one and set up one of many possibilities. You could say 8 to 12 would have to equal W to 36, because I'm going width over length equals width over length, width over length, and then solve this one. Okay, cross products will work. 8 times 36 has to equal, come back over here, 12 times W. Now, in the olden days, we wouldn't go ahead and multiply the 8 times the 36 yet, because I know I'm going to have to divide by 12. And when I do that, that simplifies to, let's see, 12 into 36 is 3. You should get exactly 24. That this is 24 centimeters, which happens to be choice B. I want you to show me some work, though, to justify your answer choice up here. All right, next is number 3. The distance between two cities is 600 miles. On the map, they are 4 inches apart. Hey, stop right there. I have 2 pieces of information here. The cities which are 600 miles apart are 4 inches apart. Now, as I'm looking at this, it says, what is the scale? Oh, well, let's see. I guess I don't have it written the same way, but you know what? If I want to get 1 inch, I know that I could simply take 600 divided by 4 and figure that this is 150 miles represents 1 inch. Now, I don't have it written this way, but when I look to see what's matching up here, I see this has a 1 and 150, and so does this one, so you'd better be careful and check your labels. 1 inch represents 150 miles. Not 1 mile is 150 inches. Nope, nope, nope. So it should be B. Next question. The height of a tower on a scale drawing is 16 centimeters. Okay, so I have some kind of picture, and it says that this is 16 centimeters. The scale is 2 centimeters to 21 meters. What is the actual height? Okay, so I know my scale. I'm given this right here. 2 centimeters represents 21 meters. I'm going to write it as a fraction, and knowing that I put the centimeters on the top and the meters on the bottom. The other number that you are given, that piece of information, is 16 centimeters. That has to go in the numerator. This is what you don't know. All right, go to town. 2 times x. This product, 2 times x, has to equal this product, 21 times 16. And then, eventually, I'll divide by 2. Okay? And when you solve, you should end up with, I believe, a 168. Now, this number on the bottom has to be in meters, and then when I look at my answer, I see, yep, A. A microscope. Under a 1,000 to 1 microscope view, a cell appears to have a length of 38 millimeters. What is the actual length of the cell? So we're comparing kind of the microscope size versus the actual size or the real size. And now remember, the microscope is enlarging for us, so it's getting much larger than it is. That's why this 1,000 to 1, 1,000 is the microscope view as opposed to 1 for the real or actual one. Okay, 1,000 to 1, the microscope to the real. So when it tells me that it appears to have a length of 38 millimeters, guess what? Appears. That means I'm looking through the microscope, and this 38 millimeters is what it looks like. I want to find the real one, which should be much smaller, because in a microscope, everything appears much larger. All right, start using our cross products here. 1,000 times x equals 1 times 38. Then I'm going to divide both sides by 1,000. Now, if you remember something when we worked in the metric system, when you divide by a power of 10, you're just moving that decimal point over, which is why this ends up being 38 over 1,000. You're going to move the decimal point 1, 2, 3 spots over, 0.038. Or 38 1,000ths is written as a decimal this way. There you go. And we should be in millimeters, 0.038 millimeters. That's also A. Number 6. If an airplane in a 1-inch to 2-foot scale drawing is 8 inches long, how long is the actual plane? I need you to set this up. 1 inch to 2 feet equals 8 inches to how many feet? Oh, this is a nice one because I get 1 times x and 2 times 8, which is 16. X is 16. B, 16 feet. Number 7. The height of a tower is 18 centimeters. The scale is 2 centimeters to 27 meters. This looks similar to that other problem, but your scale is different this time. 2 centimeters, I'm going to bump this up, to 27 meters equals 18 centimeters to how many meters? All right. Our fabulous, you guys are going to be like cross product masters by the time we are through with this unit. 27 times 18. Divide both sides by 2. And these cross out, and you should get x is equal to 243. And the answer is meters because this was the value in the denominator. And I see that as answer choice C. Number 8. Now you don't have multiple choice. Now it's really imperative that you draw your picture, show your work. Make sure that you are giving me all the information you need. Monique is using similar triangles in her graphic design project. The triangles are isosceles. Oh, do you remember what isosceles means? Two sides the same. One has a base of 4 inches and legs of 7. If the other triangle has a base of 10 inches, how long are the legs? Oh my goodness, go back here. I have isosceles triangles. Okay, so let's get one drawn in here. Isosceles means 2 of the sides are equal. Okay, on this one, the base is 4, and it says the legs are 7, so it would look like this. The other triangle is bigger, and it says this happens to have a base of 10. These guys, yes indeed, are similar, and it's saying how long are the legs? Well, so what you can do here is set up a proportion. I'm going to use the variable L for the leg of my larger isosceles triangle. Now there's a lot of ways you can set up your proportion. Okay, I'm going to start with this one. Leg of the little guy over the base. So leg over base has to equal leg over base, L over 10. Okay, you could also set it up this way. You could say this leg to this leg, 7 over L, has to equal base to base, 4 over 10. You could do it that way too. Whichever way makes you happy, go ahead and do it. Multiply 7 times 10 has to equal 4 times L. And by the way, if you look down at this guy, notice 7 times 10 and L times 4. Ha! You end up with the same cross products. How cool is that? Then I know I'm going to divide by 4. All right, my leg, length of each leg up there, is going to be 7 times 10 and then divided by 4. All right, this time, number-wise, my answer is 17.5, but you are not done. Here's why. You know, in multiple choice, that label was already there. You need to do this as well. It looks like when I go back and rewrite all of this or reread this, everything's in inches. So your final answer should be 17.5 inches. Look at number 9. Oh, on a sunny day, a 4-foot red kangaroo casts a shadow that's 5 feet long. All right, hold on. A kangaroo. Oof. This could be interesting. They have like big tails and big legs, don't they? Okay, here we go. Don't make fun of my art skills. Not so good. I guess they probably have a little pouch there, huh? And then little ears, little snout. Okay, big belly. Here's their little arms. Okay, there's my kangaroo. Here's his other leg so he can actually walk. Oh, that looks kind of bad. Oh well. Never said I was good at art. The big thing here is that our kangaroo is 4 feet tall and the shadow is 5 feet. Okay? Realize this makes a beautiful right triangle. Cool. It says the shadow of a nearby eucalyptus tree. All right, so here's the tree over here. There's our tree. That tree probably has koala bears in it if it's eucalyptus, right? I don't know how tall the tree is, but I know the shadow is 20 feet long, and I'm trying to figure out how tall the tree is. So I'm going to say T for tree. Set up a proportion. You could say height is to shadow as the height is to the shadow. Or you could probably say the height of the kangaroo to the height of the tree has to be the shadow of the kangaroo as the shadow of the tree. You could do that one too. Doesn't matter because you're going to end up with the same exact cross products. 4 times 20 equals 5 times t. If you set it up this way, 4 times 20 is t times 5. Ta-da! Get your variable isolated. In order to do that, undo what's happening. Divide. And you should end up with the tree is 16. And no matter which way you do it, you should get the same answer. Wait, your answer isn't done. Go back and make sure you know what your label is. Feet, right? Yes. So it is 16 feet tall, that tree is. Okay? Look at number 10. Now, I can tell already by this picture I'm going to have issues. Let's read through it. To find out how wide a river is, John and Sally mark an X at the spot directly across from the big rock on the other side of the river. Okay, so there, oh, here's the rock right here. Then they walk in a straight line along the river, perpendicular to the straight line between the X and the rock. So this is where they walked. After walking for 20 feet, John stops, while Sally continues along the straight line for another 10 feet. Then she makes a 90-degree turn and walks for 30 feet. Goodness sakes, I'm glad they drew this picture for me. When she stops and looks at the rock, she sees that a straight line from her to the rock passes right through John. What is the distance from X to the rock? Whew. From X to the rock. So this is what we're looking for here. I'm going to call that capital D right now. But here's the deal. This triangle on the bottom is flipped around from what this one looks like. And I've already told you that I have real issues in trying to do this flip in my head. So I'm going to turn this and spin this around so that I get my 10 here, and then my 30 is here, because those are like the two legs of my right triangle, and I don't know what the hypotenuse side is. But that doesn't matter, because this 10 and this 30 now correspond to the 20 and the D. So you can set up a proportion, okay? If you want to say, for example, 10 is to 30, then you would match that up with 20 over D. Or if you want to say, hey, this short leg, the 10, matches up with the 20, as 30 matches up with D, that distance. Either way, it does not matter which way you solve, because your cross products will end up being the same. 10 times D equals 30 times 20. If you use this proportion, you'd say 10 times D equals 20 times 30. And then you're going to divide by 10. Either way, you should end up with your distance equaling 60, and we are in feet. There's your final answer. Number 11. In the gift shop of the History of Flight Museum, Elisa bought a kit to make a model of a jet airplane. Cool. The actual airplane is 18 feet long, with a wingspan of 13.5 feet. If the finished model will be 10 inches long, what will the wingspan be? Okay, so hold on. So I have really the length of the plane, right? And then, oops, I can't spell today. And then the wingspan. Okay, so if I set my proportion up this way, where I'm going to say the length is on top, that's 18 feet, and then 13.5 or 13 and a half feet, that was the wingspan. Here's the real one, here's the model. 10 inches long, 10 goes on top, that's inches. We're going to find the wingspan here. All right, your answer will come out in inches. You don't have to convert any units here, it's all good. 18 times x equals 13.5 times 10. And then to figure out what that x is, the wingspan, I'm going to divide both sides by 18. All right, and in this one I'm definitely going to say, hey, thank you, guy that invented the calculator, because I'm just don't think I'm in the mood to do all this by hand. I know that on top I get 135, but then I'm going to have to divide by 18, and you should end up with 7.5. Go back up, make sure you've got your label, feet. There we go. Number 12, if a tree in a 1 inch to 4 foot scale drawing, stop right there, 1 inch to 4 feet is going to equal how many inches over how many feet. If the tree in that scale drawing is 12 inches tall, that goes on top. How tall is the actual tree? There you go. Oh, I like this one because I just have 1 times t. That's just t. Then I have 4 times 12, Well, I don't even need a calculator for this one, 48. Now, hold on, what's my label? This is the number I was searching for, the missing piece, and this should be feet. That's a tall tree. Number 13. A group decides to go whitewater rafting on a river. The map they have of the river has a scale of 1 inch to 5 miles. On the map, the distance between the starting point and the end point of their trip is 24 inches. What's the distance? That means inches is on the top for me with my numerator, and I'm looking for the miles. 1 times m equals 5 times 24. That means m stands for 120, and make sure you label it. This is what I was looking for, and the label is miles. Ta-da! All right, the last page is the transformations, and it's a separate sheet because I had to use a separate program in order to get this. For numbers 1 and 2, it says graph the image. So when you reflect across the y-axis, that's the vertical line right here. So your point y now lands in this new spot, which is going to be y prime. Make sure you label the points y prime. W is going to be 2 more units to the right. Call that W prime. Down here, E lands right here. That's E prime. And last but not least, my Q is going to land right here, and call that Q prime. And then please finish it by connecting these 4 points. So you make this trapezoid appear on this side of the y-axis. All right, number 2, now this is a translation. A translation is a slide. You are taking each x value here, and it says add 1. Now, you got to think of that. You can either take and figure out all the coordinates of these, write them down, and then add 1 to the x value. For example, W here. W is located at the coordinates -4, 2. So if I have to add 1 to the x value, my new W is going to have an x value of -3 because I added 1. My y value, I subtract 5. So from 2, now I'll have to subtract 5, and that would give me -3. My new W ends up at this coordinate, -3, -3. Okay, now you can do it that way, or you can think about this and think this transformation is telling me to, in the x direction, which is horizontal, I'm going to move to the right 1 unit because adding 1 is moving to the right. My y coordinate is your vertical movement, and I'm saying subtract 5, which means you're going to go down 5 units. Okay, so you decide which way you like to do this. I'm just saying graph the image. So if you want to, think go to the right 1, down 5, or find the coordinates and add 1 and subtract 5, whatever works for you. But here's my new W. Your new V goes to the right 1, 1, 2, 3, 4, 5. Here's your new V, V prime. Make sure you label it with that little hash mark there. Y, I'm going to go to the right 1, 1, 2, 3, 4, 5. This one lands exactly on the x-axis. Cool. This is y prime. And J goes to the right 1, 1, 2, 3, 4, 5. J ends up exactly on the y-axis, but down 1 unit from the origin. Here is J prime. Connect the dots. I know mine isn't as clean as hopefully yours will be. All right, let's move on 2, 3, and 4. This time, please read the directions here. It says, please find the coordinates this time. So we're going to have to list them. I didn't really give you a spot on the sheet, so let's talk about this. And it says, I only want the coordinates after the transformation. So on number 3, it says move it 1 unit to the right and 5 units up. So let's go ahead and do each one of these first. 1 unit to the right and 5 up. 1, 2, 3, 4, 5. Here's my new P prime. H, 1 to the right, 1, 2, 3, 4, 5. That's H prime. K, 1 to the right, 5 up. Here's my new K. And R is 1 to the right, 1, 2, 3, 4, 5, right there on the x-axis. Go ahead and connect it so that you see the outline of your new shape. This is some quadrilateral here. Then below, what I need you to tell me are what are the coordinates of each of these points. H prime is, it appears to be 1, 2, 3, 1, 2, 3, 4, 5. So 3, comma 5, 3, 5. K prime, right next to that is 4, comma 5, 4, 5. R, over here, R prime, has 1, 2, 3, 4. The x coordinate is 5, and then 0 for the y coordinate, 5, comma 0. And the last one, P. P prime happens to be at the point 2, 2. Excellent. Can't move that one or mess that one up. So there are the coordinates of the new translated figure. For number 4, this one is going to be reflected across this line, x equals 2. Now hold on. Here's my x-axis, and here is where x equals 2. Okay? Like this. Okay? So this is the, imagine this as your fold line, and now you're going to go ahead and map things on the other side of the line. So if I start, let's start with G. Right here. G is right here, and it's 2 units to the left, so now your new G, G prime, is going to be over here. H, which was 1, 2, 3 to the right, is now going to be 1, 2, 3 to the left. So here's H prime. Q over here is 1, 2, 3 to the left, so now my new Q will be 1, 2, 3 to the right, Q prime. And R was 1 unit to the right here, so my new R, R prime, will be 1 unit to the left. And then you can connect these dots. Now, sadly, it's hard for me to draw this on this little slate that I'm using to draw, but it should look something like this. And basically now I'm after what are the coordinates of this new figure. G, H, let's see, I'll do R next, R, and then Q. Okay, my new G has coordinates 2, comma 2. My new H, H prime, oh wait, hold on. I was looking at this. My origin is back here. I think what I'm going to do is switch colors so that I can see what's going on, because right away I can tell that's not correct. Here's the origin. So my new G, 1, 2, 3, 4, and up 2, 4, comma 2. Let's get H prime over here. That's at the point negative 1, 3. Negative 1, 3. R prime is this dot right here, and that is at 1, negative 1. And Q prime over here is at 1, 2, 3, 4, 5, and then down 2. So 5, comma, negative 2. Make sure when you write your ordered pairs, please, that you put parentheses around them. That indicates that it is indeed an ordered pair and it has a specific spot on the coordinate system. The last two. Here I want you to write the rule to describe the transformation. So you really need to decipher what's my original. Okay, here are my original points here, and this is my original triangle. Now, what happened each time? To get from A to A prime, it looks like I went to the left 1 and then down 2. So if you want to say that this translation basically went to the left 1 unit, and then you went down, what do we say, 2 units? Left 1, down 2. You can describe it in words like this. Just check it with E, to the left 1, down 2. F went to the left 1, down 2. Yep. Or algebraically, you would write it this way. My original point xy gets transformed this way. I went to the left one, which means you subtract 1 from your x value. And then to go down 2 units, you're subtracting 2 from your y value or your y coordinate. So you could write it this way, or you could write it this way. Both ways are correct. Number 6, as I look at this, E went over here to E prime, F went there, R went there, Q stayed in the same spot. That tells me this looks like a reflection, because I can fold it up exactly on this line and everything is symmetric and matches up. So it's a reflection across this particular line, y-axis. There you go. Good luck. Use this as a guide to study from then. Your test will look very similar to this when you take it.